So, have you ever wondered where the actual boundary lies between high-level system planning and low-level code execution? It's kind of a fascinating question, right? When we're building these massive, complex software systems, at what exact moment do we stop drawing boxes on a whiteboard and actually start writing executable lines of code? Well, today, we are going to untangle that exact boundary. Welcome to This Explainer. I am super thrilled you're joining us today as we take a really focused, structured look at demystifying high-level design versus low-level design. Whether you're trying to figure out how large technical teams operate, maybe you're prepping to absolutely ace a system design interview, or honestly, you're just curious about how massive software systems are planned and built from the ground up, you are in exactly the right place. All right, here is our roadmap for today. First, we'll look at architecture versus design. Then we'll dive into the architect and HLD, followed by the developer and LLD. After that, we'll talk about breaking the virtual barrier, look at a quick e-commerce system example, and then wrap up with a summary and next steps. Okay, let's jump right into section 1, architecture versus design. You know, in the software world, people throw these two terms around interchangeably all the time, but they actually represent very, very distinct phases of a project's lifecycle. Just to keep things perfectly clear for us, we can explicitly map architecture to high-level design, or HLD, and on the flip side of that spectrum, we map software design and development to low-level design, or LLD. It's kind of like, well, think of HLD as mapping out the city grid and the zoning laws, while LLD is the actual engineering blueprint for the plumbing and wiring of a very specific building. They are fundamentally different realms that require a completely different scope of thinking. Now, what's really interesting about this slide is the stark visual separation between these two worlds. On the left, we've got the architect, right? They're generating top-level components and styles. And then on the right, we have the developer, who's focusing on class design, user interfaces, and the source code itself. But look right down the middle there. There is this dangerous physical and virtual barrier separating them. Historically, decisions pass through this wall in only one direction, which, as we'll see in just a bit, is literally a recipe for a brittle, failing system. Moving along to section 2, the architect and HLD. So what does an architect actually do? Well, their primary job isn't just about what the software does, the standard business requirements. It's actually heavily focused on the non-domain features. We call these architecture characteristics. We're talking about the big stuff: scalability, testability, deployability. Our sources use a brilliant metaphor here that I just love. Balancing these characteristics is exactly like flying a helicopter. Imagine being a pilot. You literally require a separate control for each hand and each foot, and changing just one of those instantly impacts all the others. So designing HLD is this incredibly intricate, sometimes overwhelming balancing act of system-wide trade-offs. Because architects are managing this wild balancing act, their typical high-level design artifacts are highly conceptual. For instance, they define the abilities, like scalability and reliability. They select the overarching architecture styles, like should this system be a monolithic layered application or should it be distributed microservices? They also define the top-level component structures, and they formally document the system trade-offs they had to make along the way. And that brings us to a really core output of HLD, components. Architects partition the whole system into these high-level modular building blocks. That might be a simple wrapper of related code, maybe a layer or subsystem, an event processor, or even a standalone distributed service with its very own database. Basically, the architect decides how to chunk the system into these coarse-grained units, setting the rules of engagement for the entire application. All right, let's pivot to section 3, the developer and LLD. When we finally cross over that boundary from HLD to LLD, we encounter a massive shift in the kind of knowledge that's required. A software architect has to possess a huge amount of technical breadth. They need to know a little bit about a vast array of technologies so they can make informed structural choices. A developer, on the other hand, absolutely must have a significant amount of technical depth. They need specialized, highly intimate knowledge of specific languages, frameworks, and coding patterns to actually get the thing built. Armed with all that technical depth, the developer takes the architect's high-level components and breaks them down into concrete executional deliverables. During low-level design, developers are the ones creating class diagrams and sequence diagrams, figuring out the internal logic of those components, designing the user interface screens, and writing the actual source code and automated tests. As a quick aside, if you ever find yourself asked to dive into class diagrams or write out core logic during a technical interview, you are sitting squarely in the realm of low-level design. The developers are the ones turning that lofty architectural vision into a working reality. But honestly, LLD is incredibly challenging in its own right. Developers have to manage these really complex structural trade-offs down at the code level. Our source material points out a fascinating balancing act here. If a developer makes their code too abstract, it enters what's called the zone of uselessness, meaning it becomes incredibly difficult for any other developer to actually understand or use. But conversely, if the code has way too much implementation and not enough abstraction, it enters the zone of pain. It becomes brittle, inflexible, and just a nightmare to maintain. Navigating away from that zone of pain is a constant, high-stakes battle for every developer. Which brings us to Section 4, Breaking the Virtual Barrier. So here is the million-dollar question. How do these two completely distinct worlds actually connect to ensure a project is successful? Remember that virtual barrier we saw earlier? Well, if decisions only flow one way, from the architect down to the developer, the architecture almost always fails. The decisions an architect makes sometimes never even make it to the development team, and those necessary on-the-fly code changes that developers inevitably make, they rarely get communicated back up to the architect. So the crucial point is that architects and developers absolutely must continually communicate and iterate together. To break that barrier, they have to act as a single virtual team, building a truly bidirectional relationship. And this is a massive takeaway for us today. An architect's HLD components should never, ever be seen as the final word. Actually, scratch that. They're really just a first draft. Developers take that draft, begin their low-level design, and they'll always discover new constraints that require iterating on the architecture. At the same time, the architect has to trust the developer and avoid becoming a control freak who micromanages class-level code decisions. Let's look at Section 5, an e-commerce system example. To really ground these concepts, let's look at a concrete e-commerce example. Imagine a system for a silicon sandwich shop. Here, the architect has established the system's structural boundaries through domain partitioning. They've basically defined discrete, high-level components based around the business workflows: purchase, make order, and deliver. They've outlined exactly how these major blocks relate to one another, but, and this is key, they haven't written a single line of code yet. Now, the architect might go a step further to isolate common business rules from local variations, setting some very strict interaction boundaries. And this brilliantly illustrates how HLD works, because this is exactly where HLD stops. It intentionally leaves the internal specialized class implementation of how a purchase is processed or how a delivery is routed entirely to the developer during the LLD phase. Simply put, the architect provides the structural integrity, while the developer provides the detailed behavioral implementation. They complement each other perfectly. Finally, Section 6, Summary and Next Steps. We have covered some fantastic ground today, separating the macro from the micro in software creation. Let's move to and see how this builds into a nice, clean summary. High-level design is owned by the architect, who uses technical breadth to define architectural styles and component structures. Low-level design is owned by the developer, who uses technical depth to handle class design, UI screens, and source code. But remember the golden rule. For the system to actually succeed, these two roles must operate in a tight, bidirectional feedback loop. Which leaves us with a fascinating final thought. If high-level design defines the overarching architectural style, like whether we build a layered monolith or distributed microservices that the developers will then build within, how do we decide which style to use in the very first place? That single decision shapes the entire future of the software, and figuring that out is the perfect launch pad for you to dive deeper into the broader, incredibly rewarding world of software architecture. Thank you so much for joining me in today's explainer, and happy